So tonight we're actually going to be talking about something very relevant to what people are thinking about, the challenges of colonizing Mars. And Scott Marshall's going to give us a bit of an overview of some of the things we have to contend with.
Good. Well, thank you very much, Wayne, for that introduction. The title of the talk is The Challenges of Colonising Mars. And I just wanted in this talk to highlight some of the issues that you need to consider and overcome as you start colonising Mars. For some reason, it's suddenly... Oh, there we go. So, look, I had two presentations. One, this longer version, and a bullet point form version. And I decided to go with the longer wordy version because then you can read the detail on the screen as well as hear me talk about it. And I thought that might be a little bit more appropriate. So apologies if you're used to bullet point presentations. Okay, so this discussion is not designed or expected to answer the question of whether humans can or cannot live on Mars. The discussion is just to highlight the obstacles that need to be overcome to get to Mars and then to habitat Mars, which are very significant. Now, you might remember a couple of years ago, I did a number of talks on the Apollo mission. And one of the reasons I wanted to give those talks was because it was a technological marvel that we got man to the moon with the technology we had at the time. Don't forget that when President Kennedy said we're going to get man to the moon and back safely before the decade's out, 9 years, all we'd done is strapped an astronaut to an ICBM and had a 90-minute ballistic launch of a person on the top of a missile. That was it. A lot of other technology was underway, but nothing was proven at that stage. But we did get man to the moon and back within the 9 years, which is great. Getting to Mars and back is a far more difficult proposition. The issues for a Mars mission are technical, financial, social, physiological, and psychological. There are a couple of ideas on what a mission to Mars would look like. The top picture here is NASA's view of what a colony on Mars would look like. And it's very NASA-like. It's just a couple of scientific modules. The other photo is what Elon Musk would like, which is almost something out of a science fiction movie, and it's certainly not going to happen in my lifetime. But it's what Elon would like to do with Mars. So, just a bit of a background on Mars, first of all. It's about half the size of Earth in diameter and circumference. It has the same amount of dry land as Earth because it is a desert planet. It doesn't have oceans. It's about 1.5 astronomical units away from the Sun. It has a similar core to the Earth, made of iron and nickel. It has rocky surfaces, as we've seen in the pictures. It has a thinner atmosphere than Earth, mostly composed of carbon dioxide. The atmospheric pressure, Mars at the summit of Olympus Mons, its highest mountain, is 72 pascals. Earth at sea level is 100,000 pascals. So that's actually one of the major problems with going to Mars. It's the lack of atmosphere. It is colder than Earth with an average temperature of minus 63 degrees C. The Earth's average temperature is plus 15 degrees C. The polar caps on Mars are made of ice and some geological features like volcanoes and canyons. It does have two small moons, Phobos and Deimos. The solar radiation at the upper atmosphere is 43% of Earth's due to the distance from the Sun. A larger percent reaches the surface, but still the amount of solar energy reaching the surface is half of what reaches the surface of planet Earth. But there are no clouds, so always sunny, which is good for solar electricity. But the long duration dust storms are an extreme problem for solar panels. There's no life that we know of on Mars. It completes one rotation every 24.5 hours. Earth's is 24 hours, so very similar. The Martian days are called sols. A year on Mars lasts 670 sols, which is the same as 687 Earth days. The axis of rotation is tilted at 25 degrees, which is almost the same as planet Earth's tilt. The crust is made of iron, magnesium, aluminium, calcium, and potassium, and the crust is from 10 to 50 kilometers thick. And this is an interesting one. Because the atmosphere is so thin, heat from the sun easily escapes this planet. If you were to stand on the surface of Mars at the equator at noon, it will be 24 degrees at your feet and 0 degrees at your head. So they're all the things that are similar between Mars and Earth. As a planet, it's very similar in many respects to planet Earth. But it has no global magnetic field today. It did have a magnetic field 4 billion years ago and an atmosphere. But Mars' smaller size meant it cools more rapidly than Earth, and its core froze, removing the dynamo that creates a magnetic field on planet Earth. The loss of the magnetic field led to the atmosphere being exposed to the solar wind, which stripped the atmosphere away over a few 100 million years. Mars's atmosphere pressure is now 0.6% that of planet Earth. And just looking at the composition of that sparse, almost vacuum, which we call Mars's atmosphere, it's 96% carbon dioxide and a bit of nitrogen, whereas planet Earth has 78% nitrogen and 21% oxygen. So very different atmospheric composition of what there is of the atmosphere. So why go to Mars? Well, there's a lot of good reasons. First of all, because it's there. And if you think that's a strange reason, just ask the English and the Spanish and various other civilizations why they ventured out from their homelands. For the adventure, human spirit, we seem to want to conquer every land that we find as human beings. For the challenge, for the financial gain, this is the big one that people normally talk about, humanity's plan B. If Earth is no longer suitable, we need to find somewhere else. Military and political dominance, very sad, but true. Stepping stone to the galaxy. But then why did we go to the moon, and why was the Apollo mission terminated? Well, we went to the moon for various of those reasons, but why was the Apollo mission terminated? And this is an important thing that sort of filters through bits of the talk coming up. Apollo was finished at Apollo 17 because the American citizens basically lost interest. They didn't want to fund the rest of Apollo. So the Apollo rockets that were in the process of being built at the time are now in museums. Elon Musk and his Starship enterprise is somewhat successfully designing and building the rocket technology needed to launch from Earth and land on Mars. Musk's target in 2019 was an uncrewed spaceship to Mars in 2024, humans to Mars in 2026, and then build a self-sustaining population. In 2020, Elon Musk stated his aim of sending 1 million humans to Mars by 2050. That would involve building 1,000 Starship rockets over 10 years, so it's 100 per year, and launch 3 Starships per day. But Mars and Earth only align for trips, efficient trips, we call it that, every 26 months. While possible, the technological challenges are orders of magnitude more complex and costly than the relatively simple trip to the moon. And we need to think of the rocket booster technology, life support while in space, the re-entry, Mars landing on soil. And just on that, note the complexity of landing NASA's mobile probes on Mars. That was not an easy task, and the way we did it was basically cocoon it within a balloon and drop it. Okay, there were rockets involved as well, but you dropped it and let it bounce around. Not an ideal way to land humans and equipment. There's the issue of, can you actually extract fuel from Mars resources to get back to Earth and to fuel the population on Mars? And a big one is financing, and I'll just explain why that's a big issue in a couple of charts coming up. There are other issues as well that need to be overcome to get to Mars successfully. In 2022, NASA published its vision to get astronauts to Mars at the end of the 2030s or early 2040s. Their document had the following points. First of all, the round trip, 500 days or 18 months. They live in a pressurized rover while on Mars. We're not talking about a colony per se. Recuperation period while on Mars is not known. So the human body will become more frail, as we know, after 18 months in space. So we're not quite sure how long it will take for the human body to recuperate. The idea is for 2 astronauts to stay in orbit and 2 astronauts to get to the surface. 25 tons of supplies pre-delivered by an earlier unmanned rocket. And the Artemis 1 moon mission is a prerequisite for NASA Mars mission. In summary, what are some of the reasons for going to Mars and what are some of the challenges? Discuss all of that. The pros of getting to Mars, the good points. First of all, the length of Mars day is very similar to planet Earth's. At the time of writing this, I said there's abundant water near the surface, but a more recent study by NASA has put question marks on that. It is a plan B for humanity if we make Earth uninhabitable. There's a reliable source of energy, being solar energy. Robotics and automation can replace scarce human resources. There's plenty of available land and similar gravity to Earth. So they're the good points. What are some of the challenges? First of all, the distance from facilities on Earth and scarce technical resources. Now, what I mean by that is if something goes wrong and you need a particular spanner, that spanner is 18 months away. You can't just go down to the local hardware store. Now, obviously, by spanner, I mean computer part or radar equipment or food processing equipment that is broken. The time to travel there, 8 or 9 months to get there, or potentially much longer. It's 8 or 9 months best case when you look at the orbits of Mars and Earth. There's essentially no atmosphere on Mars at the moment. The sandstorms can last weeks. How do you repair any equipment that may have been damaged in a severe sandstorm? There is the cost. There's this chemical in the soil of Mars, which is a real problem. It's the perchlorates, it's chlorine oxide. That can kill you. That can kill bacteria. That's everywhere in the dust on planet Mars. So even if you go outside in a spacesuit, you want to make sure you don't bring any of that dust back inside the colony. Another issue is, can a small community remain sustainable? Just think of it this way. Can you plus 20 or 30 of your friends happily live in a scout hall for 20 years? I would say it'd be very difficult, but that's the sort of thing that they're talking about. Maybe a large scout hall. There's the isolation and lack of diverse activity. And there's no secondary source of supplies if technical failure or if products are used, such as food, water, computers, other supplies, medicines, etc. There is a radiation problem. There's the issue of oxygen. You need to generate your own oxygen up there, particularly if there are any leaks in the habitat, and the International Space Station will give you a bit of an idea of the issues with leaks. What happens if one of your crucial supply rockets crash lands or lands in a sandstorm? There's the inability for quick rescue. It could take 2 years if you need to vacate the planet or if a few people need to vacate. I mentioned before there's the finance. I'll get onto that in a second. There are large fuel requirements. Can any of those requirements be sourced from Mars? The expectation is yes, but just needs to be proven. There is a small issue of Mars to Earth communication. Now, this is not a big issue, but just remember it could take between 7 and 24 minutes for a signal to get from Earth to Mars, depending on where the two planets are in their orbits. And one of the benefits of the Apollo program, okay, that program cost $40 billion in currency as of probably 15 or 20 years ago. So more than $40 billion in today's currency. A lot of money. But the American economy reaped the benefits multiple times from that investment. A lot of stuff that you have around the house today is actually the result of the Apollo program. So if Earth societies can benefit from the new technologies required to get to Mars, that could be a benefit and address some of the finance issues. Okay, just a little bit more on the perchlorates, because this is important. That's a chemical that's been found in all of the Martian soil samples taken to date. It's widespread because of the dust storms. It's chlorine oxide. It's a powerful oxidizer, poisonous to animal life, accumulates in plant tissue, potentially making Mars-grown food hazardous to humans. Current methods to neutralize perchlorates, turn into a chloride, are expensive and complex. And recent research shows that perchlorates can be effectively neutralized in a simpler process using sodium molybdenate by pyridine and hydrogen gas. So that works on planet Earth, but are these chemicals available on Mars? And is this process simple in the Mars colony context? So we need to get over that problem. Perchlorates constitute 2% weight of tested Martian soil samples, so it's not a minor issue. Studies on Earth of Martian soil simulants show that the concentration of perchlorate in Martian soil is toxic to plants. It restricts significantly or distorts plant growth in all growing conditions, even at a low 0.5% perchlorate concentration. Prevents seed germination in all tested conditions, 100%. It presents a significant challenge in its use as an agricultural substitute, and I've got the name of the report where that came from. In addition, Martian soil has to be managed to create a soil profile to support plant life and prevent its tendency for crusting when water is added. So Martian soil, without generating a profile like we have soil profiles on planet Earth, can crust. It can form hard surfaces, which makes it difficult for plants to germinate anyhow. Now, apparently lichens and cyanobacteria survive and thrive in simulated Martian conditions. So people living on Mars could use lichen as a source of food. Perchlorates affect humans by affecting the ability to absorb iodine, which is needed by the thyroid gland. They can be a good source of oxygen because there are 4 oxygen atoms attached to the chlorine atom. When heated to 200 degrees C, perchlorates can suck any water out of the atmosphere. Now, there's not a lot of water there, but it can suck the water out. And when heated to higher temperatures, the perchlorates decompose and release their oxygen. So with a bit of solar energy, you can decompose the perchlorate and generate oxygen for the colony. A couple of other considerations. Mars dust. Olivine, pyroxene, feldspars, and quartz dust found on Mars reacts with water to form molecules that are known to form Earth-based mining and cause lung cancer. Mars dust particles in the air are typically around 3 microns in size and remain in suspension for a very long time. And that's in the danger zone of lung tissue. Now, I used to be a mining engineer, and one of the things we had to check was the level of fine grains of dust in the air inside the mines. Because once they get into the alveoli of the lungs, very hard to remove, and the lungs protect themselves by coating themselves with, coating the dust with a thin layer of tissue material. That thin layer becomes lung cancer over time. Since 2005, NASA has been concerned about the toxic effect of Mars dust on humans. Mars soil does contain a high percentage of water, plus the chemicals needed for plant growth. Clay layers have been found. So the soil is not all bad. It's just got a couple of things in it that you really want to try and get rid of. Physiology. Mars is cold and bathed in constant radiation. Gravity is weaker than planet Earth. This will strain the human system. Short trips to the moon and the ISS cause distortions to the human body, and they include muscle atrophy, we've known that from day one, bone density reduction, visual impairment due to pressure differential between the eye and the brain. Radiation, as you know, can cause cancer, bleeding gums, hair loss, reduced immunity. May also shorten human life by 15 to 24 years. And trips to Mars could be around 7 months, 7 months from this source. Other sources say 8 to 9 months. It depends on when you launch. These conditions will be cumulative. Radiation on the trip to and from Mars will be the more serious concern. Dr. Fong, in his article, Extreme Medicine, How Exploration Transformed Medicine in the 20th Century, said in his report, details on the effect of long-duration space flight and living on Mars on the human body. A body evolved over millions of years based on gravity of 1g. Altering the gravity has intense effects on the human body and how the body's systems communicate and operate, from digestion to cognition, the brain. The muscles, the bone, cognition, the brain, heart, balance are the first to deteriorate. Then your blood-forming systems and immunity deteriorate. And tests with astronauts show weakened immunity has resulted in the awakening of latent viruses such as shingles. The 1/3 G of Mars will have a long-term impact that we only glimpsed through the previous astronaut missions, which are short duration. Implies a comprehensive medical supply for the various medical conditions that may eventuate due to the long-term low gravity and radiation. The shorter day will affect the circadian rhythm until this adjusts. Now, that's not a major thing. The lack of ozone, magnetic field, and atmosphere accentuates the radiation hazard. And there's no outdoors on Mars as far as humans are concerned. Life will be constrained to inside the habitats or inside a spacesuit, or if you're lucky, inside lava tubes, if you can seal those off. What are the physiological impacts of 20 years or longer with no ability to move outside, except in a spacesuit for short durations? Gizmodo put out an article in December 2023 laying out some of the challenges, noting these might be insurmountable within a reasonable time frame. They highlighted some of the reasons why, and we've gone through those already. So the concept of being a difficult mission is widespread. Lewis Friedman, who's co-founder of the Planetary Society, had this to say. He likens the enthusiasm of colonizing Mars with a sustainable human population with a government system and financial model to be unfulfilled visions of man in the 1940s and 1950s. Visionary mankind believed we could colonize all of Earth, but we still do not live in Antarctica, much of the Arctic, or under the sea. But these places will be far easier to populate than planet Mars. Development of systems to support human spaceflight are largely static and certainly not progressing fast enough to support a Mars mission for the foreseeable future. So that's just saying that the challenges are not insurmountable, but not likely to happen in the short term. Rachel Seidler from the University of Florida is an specialist on the effects of microgravity on astronauts. And she says many people today fail to appreciate how difficult it will be to sustain colonies on the red planet. NASA and other space agencies are working very hard to create and test countermeasures for the various negative impacts of living on Mars. We are not there yet. A lot more research is required. Martin Rees, in his book On the Future, Prospects for Humanity, said, quote, "Don't ever expect mass emigration from Earth. It's a dangerous delusion to think that space offers an escape from Earth's problems. We have to solve these problems here. Coping with climate change may seem daunting, but it is a doddle compared to terraforming Mars. There is no planet B for ordinary people." So what he's saying there is if you think we have problems on planet Earth and hence we have to go to Mars, far easier to fix planet Earth and before you go to planet Mars. That also happens to be a view that I share. I'm not saying don't go to planet Mars, but I think Elon Musk's time frame is far too short. You'll be talking about decades from now. The damage that we're doing to planet Earth are not due to some factor inherent to Earth. Climate change and the many other impacts of humans on Earth are a function of the human psyche. Moving people to Mars, if this is possible, does not change the human psyche. We will just move the cause of the damage to Earth to planet Mars. And that is not a solution. You need to change the psyche of humans before going to Mars, or we'll just take the issues and problems with us. We need to fix our problems on planet Earth. Hopefully by then we will have the technology to move a sustainable species beyond planet Earth. Also, for those who think that terraforming a planet is a justified project in order to make the planet habitable for humans, just think of this. We are already severely impacting the species diversity and environment of planet Earth, which is one of the main justifications for colonizing Mars, the Plan B justification. But a key objective with Plan B is to terraform Mars. That is to do to Mars exactly what we're doing to Earth, serious, irreversible, and dramatic alteration of the environment. And we're not even on the planet yet. So just think of that. If we get to the planet, the first thing we're going to do is to change it so it's no longer planet Mars. So from Martin Rees, who I quoted previously, some comments on this. And this is an expert. Geoengineering a planet to make it habitable for humans and other life would mean the injection of oxygen and other gases into the atmosphere to raise the surface temperature and air pressure, among other interventions. That is thousands of years in the making at least. Another thought as well, if Mars's zone of equilibrium is a low-density atmosphere, which is what it is now, and the historic existence of surface water is proof that Mars has moved from a dense atmosphere to this current state of equilibrium, low air pressure, then terraforming Mars would not be a permanent change. Mars will just revert back to its point of natural stability. being its current state, low pressure atmosphere. You can't terraform Mars. Martian terraforming is a pipe dream, a prospect that is way beyond any kind of technology that we're going to have anytime soon. It's a nice concept, but there is not enough gas up there, and even if there was, Mars will just revert back to its stable position, which is a low atmosphere planet. I've got some other concepts on how to terraform. You don't just have to pump oxygen into the atmosphere. You can do it via other greenhouse gases, if you like, to warm the planet. You can use orbital mirrors to concentrate the sun's energy onto the surface, and that will then heat water, ice water, to liquid form. You can introduce microbes and lichens, and they will convert carbon dioxide to oxygen, replicating the great oxidation that occurred on planet Earth. You could create artificial magnetic fields on Mars, or maybe use Phobos to create a magnetic torus around Mars. These are all concepts that have been discussed. They all have problems. They all are going to take a very long period of time, and they will not create another stable position. Mars will just revert to its natural stable state, which is what it is today. There's not nearly enough carbon dioxide on Mars remaining required for terraforming, and the future geoengineers would have to somehow import the required gases to do so. It's not an impossibility, but the timeframes and technologies required preclude the possibility of sustaining large, vibrant colonies for the foreseeable future. It will be far easier to geoengineer Earth to remove the excess carbon dioxide on planet Earth. Yet mankind cannot do this, and indeed man finds travelling to Mars an easier mission than cleaning up our own planet. It will be so easy to fix planet Earth. The humans on planet Earth are not doing that. So if they're not doing it on planet Earth, are we going to do it correctly on planet Mars? Something we need to consider. We and our progeny here on Earth should cheer on the brave space adventurers. So the people who are saying that it's a difficult task are not saying do not do it. They're just saying it is going to take time and money and technology we don't have today. Cheer on the brave space adventurers because they will have a pivotal role in spearheading the post-human future and determine what happens in the 22nd century and beyond. He thinks, this is the view of Martin Rees, that the best way to colonize planet Mars is to radically modify humans through biological and cybernetic modifications to make us a little bit more compatible with whatever geotechnical engineering we can apply to planet Mars. So that raises a rather gloomy possibility. If humans cannot live on Mars, per se, we might not be able to then travel through extrasolar space, and so will remain a single planet species. Now, that's not a future that I would look forward to. And other extraterrestrial civilizations may just have the same problem. But the universe will be around for a long time. Earth will remain habitable for current life forms, complex biology, for another 400 million years before it becomes uninhabitable for complex life. That's plenty of time. That's plenty of time to find solutions. Maybe in the next 100 years we'll have the solutions at hand and the funding. A few other things. Humans on Mars may be free from Earth's legal constraints on bioengineering our DNA, nanotechnology, coexistence, and cybernetically changing the human body. That will be an interesting future. Not too many things aside. This is from Craig Ventnor, as a synthetic biologist and geneticist. not too many things excite my imagination as trying to design organisms, even people, for long-term spaceflight and perhaps colonization of other worlds. So maybe the solution is not to send humans to Mars per se, but genetically modified versions of us, which can withstand those issues I've raised. A little bit more on radiation. While we can build habitats underground to protect against radiation, as soon as you venture onto the surface, you're in trouble because of accumulating radiation. A recent study published in Nature suggests the radiation issues on Mars are greater than previously thought. The radiation problem is solvable, but the problem is still huge. And life underground or in small habitats may become miserable in the short order. Human beings don't like being locked up. Also, Martian habitats might be microbial deserts, hosting only a tiny sample of the bacteria needed to maintain a healthy human microbiome. Low gravity may impact the development of a fetus. We're talking about sustainable colonies on Mars. We're talking about children being born on Mars. The fetus in a lower gravity environment is likely to sit higher in the mother's womb, pressing against the diaphragm. Lower gravity may also confuse some of the critical signaling in the fetus as it develops. It's supposed to drop on week 39. There's a process of bone and muscle development, and there's the construction of the circulatory, the blood system within the fetus. Children born on Mars may never be able to withstand the forces of launch or to live in a 1G environment. The truth, we don't know. We're speculating. We haven't had a birth in 0G yet, or low G, I should say. Where will we locate the habitat? We have to have access to enough water. You have to move far north for that to happen. But the further north you go, the colder it gets, and the less sunlight, i.e. solar power, there is. And the slower plants, i.e. your food, will grow. So there's a lot of places you can put the habitats. I mentioned the lava tubes before. You could mix dust with a bonding agent to form a concrete. You can create ceramics on Mars. And 16 feet of soil is equivalent to Earth's atmospheric protection from radiation. So if you want to cover your home with soil, you need 16 feet of it. A couple more things here on radiation, but I think we're pretty au fait with the issues of radiation. NASA's taken a particularly optimistic view. In 2018, the chief scientist said that humans will absolutely colonize Mars, and the first colonists are probably alive today. Mars is an attractive second option for the human race, and the plan is to send humans to Mars by 2040. But that depends on several factors. Can you land a 1-ton vehicle on NASA can currently land a 1-ton vehicle on Mars, but we're now talking about far larger weights to land on Mars. There's the design of spacesuits, and we did have someone talking in our society a few months ago about some spacesuit design that they're working on. There's the dust storms, and you need to build the entire infrastructure for modern functioning society. Landing on Mars is very problematic due to the very low atmospheric pressure. You cannot effectively use the atmosphere to slow down a landing rocket. Landing the current Mars rovers was very problematic, and I said it was basically a couple of rockets and balloons and bouncing on the surface. Not a good way to land astronauts on Mars. And a key problem is, even if you had enough propellant to soft land, a key problem is managing the fluid dynamics and attitude control of the descent vehicle during the supersonic retropropulsion phase. That's to say, while the rockets are firing and you're landing on Mars, because the atmosphere is too thin. There's nothing to push against. Interesting, NASA is working with a US company to print proteins, fats, and starch using 3D printer technology. And that sounds interesting. and hence that could be used on planet Earth as well. Also, NASA's looking at converting the carbon dioxide there to oxygen. And if that's the case, then they plan to launch a conversion plant to Mars 2 years before the astronauts to produce enough oxygen to sustain them when they land. Okay, a couple of non-technical considerations. First of all, the social and legal infrastructure. A functioning society needs a legal system, a governance system, that's politics, and most importantly, an accepted set of norms. A colony on Mars will not be governed by US laws, and there is no international agreement for a detailed legal system that will apply to a society based on another planet. So the legal and political system needs to be established and agreed. Early human civilizations were based on a feudal kingdom system of governance for a very good reason. Democratic systems have only evolved after a period of time after certain social targets were achieved. What system of governance is appropriate for an advanced society being established in a very isolated location? What system of social norms are appropriate for society confined to a small area with limited freedoms? And if a private company establishes the first Mars colony, what legal rights will the people have? And what rights will the company have over the people? Will there be a legal system or contractual arrangement? Would human rights or rights of dispute management exist in that framework? Okay, this is a curly one. This is financing the venture. There are two ways to finance a colony on Mars. One is government funded. That's US, Europe combining, China going alone or with some of its allies. The problem for a US funded mission is the ongoing interest and motivation of the people. I said before, the Apollo program lasted from January 1967 to December 1972, 5 or 6 years. Apollo was cancelled at Apollo 17, largely due to a lack of interest from the US population, who were of course funding the program. Their interest lasted for 6 years. What happens to a US-funded mission to Mars when the US economy has its own financial problems? Let's say there's a recession, or the US populace just loses interest. To get an idea of the problems of US government-funded programs over the long term that do not have a direct social support structure, just consider the Mars Sample Return Program to return soil and rock samples from Mars to Earth. The timeline is to get a mission in space by 2036, being a favourable period of orbital conjunction between the two planets. At 16th of April 2024, the US government cut funding for this relatively cheap but important program. Now NASA has to work around the funding cut. So that's a cheap program, and the US government cut the funding. Could be privately funded. This could be one of private citizens funding their own trips to Mars. That's Elon Musk. Or it could be a concern who wants a financial return, or it could be a mixture of both. Apart from the financial reward from the new technologies that will be developed and sold, it is difficult to think of a financial reward from a long-term mission to Mars. Now, I did say that the Apollo mission generated a lot of technology advances, which are now commonplace in our modern society. We have that because NASA gave that technology to the world. If you want a financial reward from a mission to Mars, you ain't giving that technology to the world. You're going to sell it. So that's a consideration. The Committee on Human Spaceflight, or the National Research Council, estimated the cost of a Mars colonization would be hundreds of billions of dollars. A study by Cambridge Uni in 2010 estimated the cost at $500 billion. it is not clear how this will be justified or funded. I have a quote in a magazine that I bought a week or two ago from Dr. Krumigis. He's the emeritus head at the space exploration sector of Johns Hopkins University Applied Physics Laboratory. He said, trip to Mars, some estimates place it at $1 trillion US. So that's the cost of getting a colony on Mars. So why do I say it could be a problem? Can't the US just fund this? The US is a major superpower. This is a chart put out by the US government of the projection of their debt going forward. That vertical line is where we are at the moment. The blip about 1/3 the way along the chart is the Second World War. This is US government debt as a percent of GDP. We are now at the equal highest level of debt in the United States as a percent of GDP that the country has ever had. That blue line shows that if nothing is changed, US government debt will go into completely uncharted territory. It's very hard to justify a $1 trillion expenditure when your debt is doing that. A few other things. I won't go through all of these things. It's been estimated that the colony size to be self-sustaining needs to be roughly 110 people. That's for the colony to have all the systems, all the manufacturing, the energy production, the maintenance, the social activities and everything. You need a minimum of 110 people. There needs to be a commitment to move this minimum number of people in a relatively short period of time to Mars and to sustain them there. You talked about the communication. It's not a real problem. You would give up the whole concept of maintaining a pristine Martian environment if you take 110 people to planet Mars, and especially if you want to start terraforming. So just a couple of concluding comments. I don't want to sound completely negative and dismal in this, but I just wanted to highlight that things are difficult. Getting people to Mars, it will take a bit of time. As I said at the beginning of this talk, I do not want to press the case that establishing a colony on Mars cannot happen or is impossible. My aim was just to highlight that there are many barriers to overcome, and this will take longer than many expect, I believe, and from my reading. The technology barrier is but one of many. A successful Mars colonization program will need the commitment of a large percent of the population, not just the visionary enthusiasts. Will this AI vision of a Mars colony ever be built? Well, I hope so, eventually. Humanity is a species on the move and has always accepted the challenge. But it's not an easy path to travel. So that is my talk. Thank you for letting me give that talk.
Thanks, Scott. Just have to see the questions at the moment, whether we go through the questions that have been raised. Can you have a look there and just have a quick look, or do you want me to read them out?
13, 14.
Yeah, let's go through those and then we'll make some other comments afterwards, I suppose.
Did the dentist check water, fluoride, and nutrition status? Elon Musk's latest brain hack is for eyes thought to help overcome radiation damage. Yeah, there's a lot more issues than just what happens to eyes with radiation. As I mentioned, it affects several parts of the body, and it's a difficult thing to overcome. Not impossible, but you will need spacesuits of particular material to avoid the radiation. You would need 16 feet of soil or the equivalent in concrete, steel, whatever you're going to build your structure out of. So you need to have a lot of protection against the radiation. And you're going to be in that high radiation space for, pick a time frame, 10, 20 years. You're not going to be able to hide from it. 3D printers, yeah. Imagine if you could make food with 3D printers. You have a 3D printer in the corner of your kitchen and just program your chicken Kiev, and out it comes. Interesting concept. Well, maybe not a chicken Kiev, a block of green protein, maybe. What caused the loss of the magnetic field? Okay, planet Earth has a solid iron core, iron nickel core, but a liquid zone beneath, mantle beneath the crust. Cause of that, there is relative motion between the core and the surface. The core is spinning or moving. I wouldn't say spinning. It's moving. It's moving enough to create a magnetic field, and that's what gives us a magnetic field around planet Earth. Because Mars is smaller, that liquid mantle, which allowed the iron nickel core to spin, solidified. So it no longer has a spinning core. It no longer has a magnetic field. So that's what happened there. Soon it's speculated somewhere that it was from a massive solar eruption event and lack of magnetic field because it doesn't have a spinning. Oh, there we go. So that answers the question. Radiation damage to brain cells will surely impact thinking functions. Yeah, that's the cognitive issues that I talked about. Not sure how that will affect brain function. As the scientists say, it's a new sphere. We haven't hooked human brains in magnetrons over a 2-month period yet to see what the effect is. So it's all very up in the air. Hear about solving your problems here. Yeah, look, I'm sorry about ranting and raving on about that, but heck, we've got a lot to do here before we spend money on going to Mars. That's sort of my view. Agree, we can explore space and resolve sustainable human habitat at the same time. You need to restart Mars's dynamo. That ain't going to happen. Now, I don't understand the physics behind using one of the moons of Mars to create a magnetic torus around the planet. That's one of the things that some scientists are speculating. It sounds a little bit science fiction, but who knows? Who knows? I'm thinking building several massive space stations between Earth and the rest of the solar system, far more likely to occur before. Yeah. There's a couple of things there. First of all, if we build our own space stations, will cost a lot of money. The International Space Station has shown that over a period of a couple of decades, they do tend to puncture, which is a problem. If you're living somewhere out near Neptune or Saturn and your space station starts to puncture, it's a bit hard to bring it home for a service. And you do have the other problems of being in a confined space as well. It has to be a very, very large structure. But yeah, it's not impossible, and it may well be cheaper than trying to colonize Mars. We have brain hacks like cochlea for ears, so similar eyes for the fragile as you imagine will soon. Yeah. The brain's a little bit more complex than an ear or an eye. You can certainly fix your ears and eyes up, and anything else on the body you can fix. I'm not a biologist, but I would suggest that it'd be very hard to fix the brain. Now, we do know that when people have strokes, if they work very hard, they can themselves repair the damage to the brain from the stroke. You can learn to talk again. You can learn to walk again. So you can reprogram the brain. It is possible. But if you've got a little bit of damage over all the brain, you then don't have those other bits of the brain fully functioning to use and reprogram. So speak to a biologist on that one, I think. Can you use other parts of the brain? Can you train other parts of the brain to replace damaged sections if all of the brain has been damaged? Someone will have to explain what EpiPens means, sorry. I predict huge space station servicing mining operations. Yeah, quite possible. Quite possible. Thank you. Thank you for that comment, Lou. The beginning of a permanent Mars colony will be creating the sustainable infrastructure through robotics. Yeah, very likely, very likely. Once sustainable is at required levels, starships offer food and water just right. Yeah, yeah. Look, we can do it in stages. We almost have robotics at the stage where they can do most of the functions of humans in the concept of managing a space colony. You're getting close to that. So yeah, send up 50 robots, whatever, and do the preliminary work and see if that works. Give it a go. I'll be all for that. You mentioned a 400 million year period in which complex life on Earth is. Where does this number? Okay, that's a number that I've read several times. I do a lot of diverse reading. Complex life, multicellular complex life, has been around on planet Earth for plus or minus 400 million years, maybe 450 million years. Planet Earth is halfway through the time period when complex life can be sustained on planet Earth. In 400 million years, this is not part of going to Mars, by the way, the conditions on Earth, because of the changes in the sun, because of various changes that happen to planet Earth itself, complex life probably won't be able to survive in 400 million years. So enjoy the next spell. That'll be the end of it. So we do have to get humans off planet Earth within 400 million years, or whatever our robotic descendants are. A lunar base built before Mars? Absolutely, absolutely. I'm not sure whether it's the Chinese or Americans who do that first, but absolutely. Yeah. Were there any other comments that I've missed? Oops, here we go. Just mentioned it didn't come up. Yeah. I think I've got to the end there, Wayne,
Yeah.
unless I've missed some.
Thanks, Scott. Yeah, I think that's probably a pretty good. So, I mean, the realistic situation, really, for those who want to look at it, is that, I mean, obviously, we're trying to get the cost of spaceflight down, and that the key thing at the moment is because spaceflight is so expensive, even doing stuff in low Earth orbit or going to the moon is too expensive at the moment. As soon as we can get the price down, it's then going to change possibly moving away from the governments to be involved with spaceflight to private industry.
Yeah.
At the
Yeah.
moment, the idea that the US government can fund a Mars colonization is a problem when you've got the two richest men on the planet, Bezos and Musk, who've probably got as much money as the US government's got, personally, okay? So the problem you've really got is that distribution of wealth is part of the problem, but the reality is we need to bring the cost of going into space down, and but in the short term, because of the problems of distance, the return to the moon is probably the most logical option, if not building a space station.
Yeah. Yeah.
That's really what to look
And
at.
I can barely hear you.
Who, me? I'll get closer. That's all right.
There's a comment here, and I've mentioned it very briefly in passing. This is probably why we haven't met aliens yet. Yes, it is difficult to move through a couple of light years of space, assuming you're coming from the closest planet. But we haven't seen robotics, sorry, not that we know of, we haven't seen robotics or similar things either.
Yeah, okay. So I think, has anybody else got any comments and questions? I think that's pretty much covered everything.
Perhaps I could just add a point. Scott, very interesting, lots of information, very dense, but interestingly presented and well done. I was going to say that the point you made about, and others, Martin Rees and so on, about the easiest, well, it being much easier to fix our problems here on Earth rather than going elsewhere. To create a colony is a really important one, very cogently put. And also the one that you mentioned also about you know, we're also on track to destroying Earth as being a habitable planet. So why would we believe that our terraforming exploits would actually provide a habitable Mars, rather than another even more uninhabitable Mars? It's a very well put couple of points.
Well, no, thanks for that. Okay, on planet Earth, humans are pretty much everywhere, and humans are really, really, really good at using the available resources, and that's why we've pretty much stuffed up planet Earth. We just used up all the available resources that are here. Now, I was going to say that, yeah, we go to Mars, at some stage we terraform planet Mars, and then what do? We go and use up all the resources. But that will require a very large population on planet Mars. I mean, if you're going to terraform, that basically means you're going to stuff the planet up, because it will no longer be Mars. There won't be enough people to then use the resources and do to Mars what we did to planet Earth, but it won't be Mars anymore. It's an interesting problem. The one savior for planet Earth, and this is going off topic a little bit, but I think it's important. And I think most people in this group would have read the same stuff that I read. The one thing that's going to save planet Earth over the next, let's say, you can pick a time frame, 40 to 60 years, is that the population is going to absolutely crash. So we won't be using all the resources we're using today. We're going to be using maybe a third less of the resources in 40 or 50 years' time, because the population will be that much smaller. So that's the one savior for planet Earth.
We'll have to see whether it's going to crash as quickly as that, though. There might be attitudes towards population control, but I can't.
Oh, no, it's not population control. The problem is that the number of babies that people are having around the world.
Yeah, they're reducing. I know that.
Yeah.
I'm not sure whether they're reducing quite at the rate that you're talking about, but they're certainly going down, yes. In some countries that are really, India and China are the two big ones where the population is really huge. Yeah, okay. We'll have to...
You need 2.1 children per couple, or per woman, it's the same, to sustain a population, 2.1. In Korea, Taiwan, it's around 1.2, 1.3. In China, it's 1.6 or 7. The population is going to crash. And also in Europe, by the way. In Europe, it's well below 2.1.
Which is actually a good thing, unless we have a lot of people coming from, I mean, this is going to sound bad, but unless we make it up from other countries which haven't gone through this industrialization phase. In other words, it massively increased their populations by a factor of order 100 compared with, 1,000 years ago.
Well, I think it's a great thing. I think planet Earth will be happy to have 2 or 3 billion humans rather than 8 or 10.
Yeah, no, I think that's right. The planet will be happy, assuming the planet is happy. It can think.
So I'm going off topic, Wayne.
It's all right. Paul's got a question. Paul?
Well, not so much a question as an observation, and that is, according to Elon Musk, what we're going to lack in humans, we're going to make up for in robots.
Oh, yeah. Well, yes. Half of all the robots traded around the globe at the moment are going to China, because their population is going to crash worse than most other nations. So they're making that up by buying robotics to replace the workforce.
I did have an observation as well, and that was that it seemed to me going through your talk that about half of the problems that you were talking about in terms of Mars would have applied to Antarctica in the first half of the 20th century.
Yeah.
In terms of the isolation and the small population and so forth.
standard psychological thing.
That's right. When you look at size of, let's call it a colony, whatever, the isolation, the availability of immediately available resources, all the rest of it, yes, in many respects similar to Mars. The big difference is if anything goes wrong, help is one phone call away.
Yeah, exactly. That's the thing, is like in the second half of the 20th century, we wound up with much better communication and much more air transportation. So it alleviated a lot of the Antarctic problems.
Yeah.
Well, I think technology's advanced a lot in the last 20 years. In fact, some of the things that I was looking at a spacecraft entering the atmosphere and looking at a plasma field. I don't think, if you think about it, I don't think I've ever seen plasma and a re-entry before until Starship entries. I mean, there's we have made some advances in the last 5 or 6 years even, but you've got to remember the advantage with some of the things we're talking about with cislunar space is it's the distance and the amount of time it takes to get there. Mars is so far away; it's a number of 7 odd months at least. That's where the problems are coming from. Okay, any more questions?
There's a couple of comments that just come through.
Yeah, okay, I see that one.
As someone who lived on the North Pole, getting help is not easy in extreme weather. Yep, no, thanks for that.
Finland.
Thank you, Ken, for your comments. I think the philosophical position that Mars will no longer be Mars if we terraform is questionable. What are the value of ethical premises given we mine this planet all the time? Yeah, interesting comment. If Earth is no longer Earth because of what we're doing, should we be concerned about Mars not being Mars?
I suppose it depends what you're trying to achieve. Anyway, I think the main thing to note about today's presentation was it was designed to make everybody think, which is what it's certainly done.
Oh, yeah. Look, as I said a couple of times in the presentation, I don't want to quash the idea of going to Mars. Absolutely not. As for those who have heard my talks in the past, I'm absolutely a fan of whatever man does in space, but just got to sit down and think of the challenges.